Hi. In this video, we will learn more about MCB and the different features of miniature circuit breakers. Circuit breakers are essentially safety devices of any property that uses electricity. These fixtures act as the third party within sophisticated and dangerous electrical wiring systems. MCB stands for Miniature Circuit Breakers. The MCB is an electromechanical device that switches off the circuit automatically if an abnormality is detected. The MCB easily senses the overcurrent caused by the short circuit. The miniature circuit breaker has a very straightforward working principle. Additionally, it has two contacts, one fixed and the other movable. If the current increases, the movable contacts are disconnected from the fixed contacts, making the circuit open and disconnects them from the main supply. All fuses need to be replaced with MCB miniature circuit breaker for better safety and control when they have done their job in the past. Unlike a fuse, an MCB operates as an automatic switch that opens in the event of excessive current flowing through the circuit, and once the circuit returns to normal, it can be reclosed without any manual replacement. MCBs are time-delayed tripping devices, to which the magnitude of overcurrent controls the operating time. This means these get operated whenever overloads exist long enough to create a danger to the circuit being protected. Therefore, MCBs don't respond to transient loads such as twitches, surges, and motor starting currents. Generally, these are designed to operate at less than 2.5 milliseconds during short-circuit faults and 2 seconds to 2 minutes in case of overloads, that it depends on the level of current. Let's take a look at the internal structure of an MCB. You can see in the photo the electrical and mechanical parts, and also 4 rivets that you can open and view the inside of an MCB. If the 4 rivets are damaged, you can split them in half, as shown in the figure below. The parts are embedded in the left cover, and the right cover can be removed. Here you can see the circuit part of an MCB. When the contact is closed, the rated current flows in the circuit. When the contacts are separated, an arc current is generated between the contacts. The current path initially runs through the arc path. After the arc is introduced into the arc extinguishing chamber E due to magnetism, heat, etc., the current path is E and F. The arc is divided into 10 segments in the arc extinguishing chamber, which are quickly cooled and extinguished. After the arc is extinguished, the current is completely interrupted. Now you can see the mechanical part of an MCB on this photo. The function of the mechanical part supports 2 operations of manual on and off, and automatically perform thermal trip and electromagnetic trip for protection in case of overcurrent or short circuit. It also has thermal trip current fine-tuning operation. This function is not commonly used. The housing size is in line with industry standards. In order to unify standards and improve processing efficiency, circuit breakers less than a certain rated current will use the same shell, contacts, and terminals. The maximum rated current that this enclosure can pass is the frame-level current. In this example, 63 in the model DZ47 LED 63 means that the current of the shell frame of this series is 63A. After the shell is disassembled into the left and right halves, it can be seen that most of the 2 halves are symmetrical. According to the function, the internal space can be roughly divided into 4 bedrooms. You must check type of load, whether it is single-phase or 3-phase load, to be able to have a suitable selection of a miniature circuit breaker. It should be capable to carry the rated current of load. Therefore, check number of poles for a miniature circuit breaker where SP is single pole, which means only phase wire will be connected. SPN is single pole with neutral, where phase will be on or off when MCB will operate, but neutral will not isolate as it remains connected. DP is double pole, which means phase and neutral wires will be connected, and on fault both phase and neutral will be isolated. P is triple pole, which means 3 phases will be connected with MCB and neutral will be separated from MCB. TPN is triple pole with neutral, where 3 phases and neutral are part of MCB, but 3-phase will operate with MCB operation and neutral will remain connected. 4P is 4-pole, which means 3 phases and a neutral will be connected, and all 4 poles are linked with switching on or off operations. A short circuit is an electrical circuit that allows a current to travel along an unintended path with no or very low electrical impedance. This results in an excessive current flowing through the circuit. The opposite of a short circuit is an open circuit, which is an infinite resistance or very high impedance between two nodes. Short circuits can be caused by vermin or pests chewing through wires, water or other fluids coming into contact with electrical wiring, loose connections in an electrical box, old or damaged outlets, switches, lights, appliances, or other electrical devices, nails or screws piercing through walls and coming into contact with wires, deterioration of electrical cable sheathing, buildup or surges of electricity. Fault current or short circuit measures in kiloampere, which means that a MCB can withstand the fault current of short circuit. For an example 40, a dp MCB with tank of fault current. Note that MCBs are available with 10K fault level. The maximum permissible current in a circuit breaker depends on the ambient temperature where the circuit breaker is placed. Ambient temperature is the temperature inside the enclosure or switchboard in which the circuit breakers are installed. The reference temperature is 30 degrees Celsius. When several simultaneously operating circuit breakers are mounted side by side in a small enclosure, the temperature rise inside the enclosure causes a reduction in current rating. You must then assign the rating, already derated if necessary according to ambient temperature, a down rating factor of 0.8. A typical range of single-phase MCBs are 2A, 6A, 10A, 16A, 20A, 25A, 32A, 40A, 50A, 63A. Furthermore, a typical range of three-phase MCB are 1A, 2A, 3A, 4A, 5A, 6A, 10A, 16A, 20A, 25A, 32A, 40A, 50A, 63A. The following figure shows the rated current of standard miniature circuit breakers at 30 degrees Celsius and with rising and falling ambient temperature. As you can see, the rated current of a circuit breaker decreases with increasing ambient temperature and increases with decreasing ambient temperature. There are many types of circuit breakers, while MCBs are classified into three major types according to their instantaneous tripping currents. They are an electromagnet with plunger and Schur's instantaneous tripping in case of short circuit. The BSEN 60898-1 distinguishes three different types, following the current for instantaneous release. Type B, CD. The CD curves shows the range of fault current on which a circuit breaker trips instantaneously. B curve. In this curve, a MCB trips when current range is between 3 to 5 times the full load current. It is suitable for domestic applications where a 10A MCB will trip on 30 to 50 A fault current. C curve. In this, CB trips when current range is between 5 to 10 times the full load current. Type C curve MCB is suitable for commercial applications, like starting current of motors, fluorescent lights, etc. D curve. In this, CB trips when current range is between 10 to 20 times the full load current. Type C curve MCB is suitable for industrial applications, like transformer, X-ray machines, large battery charging system, large winding motors, discharge lighting, etc. There are also other curves for MCBs that use them for specific applications. These types are K curve. In this, CB trips when current range is between 8 to 12 times the full load current. Z curve. In this, CB trips when current range is between 2 to 3 times the full load current. S curve. In this, CB trips when current range is between 7 to 13 times the full load current. Note that selection of type of BCD circuit breaker should be very carefully. Wrong selection of CB will create issues in operations. For example, if B-type CB is put in for C-type CB applications, then type B MCB will trip again and again on surge or temporary fault, which is not required for the system. Same way, if type C CB will be put in for type B, then type C will not trip on fault and equipment will be burnt. The release is initiated by a bimetal strip in case of overload. The standard defines the range of release for specific overload values. Reference ambient temperature is 25 degrees Celsius, 30 degrees Celsius. Now it is the time to read MCB nameplate rating. 1. Model number. All reputed manufacturer has a particular code of each device type. It will be very easy to communicate with seller or manufacturer if you quote the model no, in case of any service complaint. 2. MCB current and curve rating. As shown in example, it is mentioned C20. First letter is showing the characteristics curve. There are 3 characteristics curves in common use. Available BC and DB curve indicates that short circuit rating of device is in range of 3 to 5 times of standard rated current, which means timmer for trip initiation, i.e., the less rating of the time will be fast acting, like for protecting sensitive electronics devices and equipment. C curve indicates it to be 5 to 10 times and D curve indicates it to be 10 to 20 times. Be very careful while selecting this. On a resistive load, say heater, normal lighting load, it will be curve. For inductive load, like pump, motors, etc., it will be C curve, and for highly inductive or capacitive load, it will be D curve. The numeral part indicates rating of MCB in ampere. In the given example, it is 20A. MCB rating is very important, and be very precise about it. 3. Operating voltage. It is in volts and is the operational voltage for which current rating is set. In 3-phase, it is usually 400 V or 415 V. For single phase, it is 230 V or 240 V. Choose as per your application only. 4. MCB braking capacity. Braking capacity can be defined as the maximum level of fault current which can be safely cleared. It is written as in numerals, like in an example, it is 6,000. It means at 6,000 it equals 6K. Choose braking capacity as per your fault level possible. Since it is the parameter which may increase or decrease the cost, so it should be properly decided. Braking capacity should be higher than the possible fault level. For domestic application, where fault level cannot be calculated easily, it is advisable that go for a standard braking capacity of 10K, which is easily available. Please note that this rating is mentioned as per testing made on basis of IS 60,898. If it is for IEC 60,947-2, then it need to be mentioned separately. 5. Energy class. MCB normally work on current limiting feature. It means that it does not allow fault to get its peak and trip before that. But since there is some time consumed in tripping, fault current will create some energy which will exist in system. This energy is termed as let-through energy. For efficient MCB operation, it should be limited. On basis of amount of energy, it is classified in Class 1, Class 2, and Class 3. Here Class 3 is best, which allows maximum 1.5 L-joule per second. This is being tested as per IS 60,898. 6. Status indicator. It shows the on-off indication while in operation. Never buy an MCB which don't have clear status indicator, because serious damage may be occurred with ONOFF confusion of the device. 7. Operation symbol. This is always printed by any good manufacturer. This shows operation mechanism of MCB. 8. Additional relevant information. Information like impulse voltage, ISI marking, etc., are usually printed on side of MCB. However, there are many parameters on which quality of MCB should be judged, but aim of this blog is to make you aware of printed information on MCB. 9. Catalog number. Most of the MCB manufacturers put the catalog number of the MCB products. This code provides the overall information on the manufacturer website, such as MCB specification and datasheet, etc. Thank you for your attention. In the next videos, we will show you how to size a circuit breaker. If you like this video, please subscribe our channel and like and comment our videos.